Okay guys, thought I'd make another video. This will be on the Admiral TV, but we're going to do something a little bit different. I wanted to kind of use this TV as, well, some teaching lessons as well as, as we go through and do different videos on its restoration. Anyway, so this is going to be underneath that Admiral as far as another part to the restoration series. I've been gaining on this. This is the IF subchassis, and we've been replacing a lot of the resistors in here, and of course I restuffed these two caps, and well, this one too, right there. So anyway, got a few more resistors. This one needs to be replaced, and I still got the two cathodes down here, this one and this one, that are out of tolerance, that need to be replaced. Interesting note is a couple things. One is the various resistors that were used in here. I mean, there's a lot of just standard ones, just like you normally would see in this age, just kind of like the new ones, just your standard stripes, carbon comp resistor, just like this guy here. Get you in here. But this guy right here is a little different. You notice it's black and brown and orange. Well, that makes no sense. That color code would say 0, 1, and the orange is 3 zeros. So how does that work? Well, actually, this is actually color coded in the old way of doing carbon comps as well. Well, basically, when they went to what they call insulated or molded resistors. Your old dog bone resistors were done by a color code method called bed, body in dot. When they started producing the molded resistors like this, they stuck with that. Now, originally, in some manufacturers actually only put a dot, and it didn't take long before they realized that that was not a real good idea, because you'd have to rotate the resistor. It was difficult for servicemen to actually find the color, and some of these could be soldered in pretty tight, making it almost impossible to even rotate it. So they quickly went to a stripe, but it's still underneath the bed, body in, and in this case a stripe instead of dot. They still call it a dot even though it's a stripe. So the body is brown, which is 1, the end is black, which is 0, so that's a 10, and then orange for a stripe or dot, which is 3 zeros, so it's 10 with 3 zeros on it. That's a 10K resistor, and it's in tolerance. It's good. The other thing on this was some of the other resistors used, which were a little different. Had what appeared basically little dog bones. 2 of them are, except they're using stripes. You got blue, which is 6, gray 8, and yellow is 4 zeros, so it's a 680K. There's 2 of those. Here's another one. But they're just basically designed as a dog bone, which you could call more modern dog bone. And the other one was this guy here. This is actually, you see these in European radios a lot. It's 5%, that's what the 5 stands for. 330 ohm resistor. And so, and it was out tolerance, as well as those two 680s. Now the other thing I wanted to do with this was show you how to locate and follow a schematic and locate the parts and follow it in an actual chassis. So we're going to start at this end right here. This point right here, it hooks right directly to the tuner. This is where the signal's coming in. Is right here. And we find that on our schematic at this point right here. This 120 picofarad cap right here is inside the tuner, and the wire comes out and connects here. Now we have L4 and a cap which is C18 that is hooked right to that point. So we just take and look. If I keep it in focus, if we look right here, here's that point, that connection. It hooks right here. We're coming off of it. Well, there's an inductor for L and a capacitor behind it, connect in parallel. So that's a L6 and C18 right there. Now if we follow that down, it comes to the tube. And if we look, at the tube, our little space is right here. So here's pin 1, pin 2, pin 3, 4, and so on, around for 7 pins. Well, it's connected down to pin 1 plus that, again, 10K resistor. Let's see if we can find that. So if we look at the schematic, here we're coming from that inductor and capacitor parallel package. We go over here, we see pin 1 right here, and I hope you can see that. And there's a 10K right there. So we've located this point right here. Now 10K will go down, hook to C9, I believe it's C19, which is a 1500 picofarad cap. Which is an interesting cap. That cap goes to ground. And it says C19A. And over here is C19B. And I'm hoping you can see that. Let me rotate this down a little bit and see if I can zoom in just a tad bit more and keep focus. So C19A hooks on the other side of the 10K, goes to ground, and there's a C19B that goes to ground, and it hooks to pin 6 of that same tube. Well, let's see if we can find it. So get this down here where you can see it and get it in focus. Okay, 10K coming up. Let me zoom this out just a hair because it don't look like it's in focus. There, that might be alright. Comes up to this point, and underneath there, if you can see it, there's a wire here that goes to this cap right here. There's another wire going down to this point here, which hooks to here, which hooks to here, which goes down to here. Ground. So this is ground. And here's the other end going up here. This cap also has 2 parts. Another wire that, if you can see it, goes down to here, which if we count off 1, 2, 3, 4, 5, 6. That's pin 6. So this is a 2-section ceramic cap. The center wire is ground, common to both leads, and then these are the two 1500 for C19A and B, which you can pick out real easy here now. Pin 1 and pin 6, seeing the two caps right here. We also have pin 7, which goes to a 39K, they say, but there's a little circle with a slash there. What that means, if you go in the parts list, it shows that there's a note that they changed different runs. They changed the value of that cap, which turns out they actually did change it a little bit. But pin 7 is right back here. I can get in here, right there. And here's that resistor, cathode resistor. It's green, brown, and black. 51 ohms. So it's actually a 51 ohm. I find it rather interesting that we had a 39K originally, which I'm not sure if that's not a misprint. That's a heck of a drastic difference, and 39K on that 6AU6 would be a pretty healthy bias resistor. So, other points of interest in here. Going back around here, we got 1, 2, pin 3, we have pin 2 and 3. 3 is this connection right here. It is to ground, which it goes to ground. Pin 3 is one side of the heater. That's this one here, and it's going to ground. You can't see that. This guy here going down to ground. Pin 4 is the other side of the heater, which feeds across this way. It'll come down, go to the next tube, and down and through L10. Well, if we follow that, there's pin 4. Get some light on there. There's a black wire here. Black wire goes through to, let me move this cap out of the way, to here, which is again pin 4. Again, pin 3 on this tube is grounded. So these are two heaters connections. And then there is a L10 right there, a little choke, which then feeds over to this next tube's heater connection. Pin 5 goes into the first IF. There's a resistor there, which is in parallel. And that's this connection here. Hooking down to here, there's that resistor. There's the IF. It looks like this is going to either be a very long video, or if I don't speed it up, or a two-part. That takes care of tube 1 for all practical purposes. Pin 2 also is to ground. It is the suppressor grid on a 6AU6. So we've located all the parts surrounding this first IF tube, and how they connect. We can look on the output here of the IF. We can find that it should go in grid 1, or pin 1, which is grid 1 or control grid, and it does. It goes right here. This is pin 1, there's pin 2, pin 3, and so forth. Now, pin 2 on this tube is not grounded. It's not even connected up. That's because, and although when I cleaned the chassis I lost the printing, but if if you notice the solder right here underneath that 6AU6, this is a 6AG5 and the 6AG5. They used those instead of a 6AU6, which pin 2 and pin 7 on those are connected together. So pin 7's already connected up back here to this resistor here, which is a cathode resistor. So we didn't need to make that connection at all. Whereas on the 6AU6, it is a separate connection. It's not internally connected inside the tube, so they had to run it to ground. And that's the only difference between the tubes, 6AG5 and the 6AU6, as far as the pin layout. The other difference is, and that's really its primary consideration, they did that with the 6AG5 so that you could actually separate your input and output of the tubes somewhat, or the cathode and its suppressor grid from the input or grid 1. As far as gain, the tubes are very similar. If they're operated at a fairly low voltage, the 6AG5 has amplification factor of 2700, where the 6AU6 is 1950. But if they're operated at closer to their maximum operating voltage on the plate, then the 6AU6 actually outshines the 6AG5 by about 1200 for an amplification factor. So it runs up to 5200, and the 6AG5 is 4000. So there's not a lot of drastic gain increase by using a couple 6AG5s. They just did it to get a little bit of separation there. Now that tube otherwise is pretty well connected, the same as the first tube. In the circuit, it again has a shared capacitor here that's hooked up a little differently, but it's right here. Center pin goes to ground. This one here will feed over to pin 6, and this one feeds up to one side, the other side of the secondary on the IF transformer. The biggest thing about following through a schematic, and this is going to be 2 parts, I'm not going to make it a real long video, but the biggest thing is if your schematic doesn't have already pin numbers on the tubes, then look up the tubes and put those numbers on there. That makes life a lot easier and a lot handier. The other thing too is resistor and capacitor values. If your schematic doesn't have it, take the time to look up in the parts list to find those values and put those on. So with the pin numbers, you can locate stuff. I can find, with pin numbers, I can locate where everything's connected. Here's pin 1, pin 2, pin 3, pin 4, and so on all the way around. So I can find those different elements that are connected to it, such as pin 1's connected to this IF can right here, or IF transformer, connected to pin 1. So I can find those various points and locate them. I can find, my heaters, 3 and 4, cathode and its resistor here, and where the plate connects to the next IF, I can find that. So you can use that to locate and find stuff in here. I'm going to end this right here. We will finish up on the next video this tube, move on to this one, and hopefully get to the 6AL5, which is the detector tube right here, on the next video. So consider this kind of like a part 1 to this, or part A, if you will, as we go through the IF. And also on here is the IF of the audio circuit. So what's located on here is right in here, as well as this, and our video amp over here. So that's all located on this. So until next time, thanks for watching, and I hope you find this somewhat helpful and interesting. And again, there'll be another part to this that I will do. So be looking forward to it. It'll probably be in a day or two. So I'll see you on the next video. Thanks for watching. Have a good day.